This conference will now be recorded.
Okay, fine. Yesterday we were discussing something about data types. Okay, data types. What actually a data type? What is the use of data type in C programming language? We have seen already. We will have a rough glance what we have discussed yesterday, and we will continue with the current topic. Okay, data type. Data type is simply nothing but representation of the data what we are the representation of the type of the data what we are giving to the system. For example, yesterday we have seen like int a, right? One second. Yesterday you people asked me for this software. Okay, I will send it to you today for sure. No more extensions. I was a little bit busy. I will send it to you today for sure. Okay. Alt F new. Okay. Hash include stdio.h. I will definitely write this statements, these libraries actually have it. So don't worry. Void main. Fine. This is what actually the structure of the C programming is. Okay, we call this hash include stdio.h and conigo hash include conigo.h as header files. Okay, or precursor directives, and we call this void main as the function here. Whatever you want to convey to the system, you can convey it here in this part. Okay, and each and every statement containing this main function should end with a semicolon. Now we are going to write a data type int a. Okay, so I am defaultly giving semicolon. It means that we are declaring a variable a of data type integer. Okay, char b. I am declaring a variable b of data type character. Next one is float. I'm declaring a variable c of data type float. C of data type float. So I have declared the three types of variables here. Okay, one is integer, second one is character, and the third one is a float type of data type. So I have declared totally three variables here. Okay, so we have discussed about this in our last session. So no need to worry and no need to get confused. We will have a rough glance about this and we will go to the next topic. Okay, data types. Data type has a name, value, and a type of the variable. So name is simply nothing but the variable name. We have given a, right? That is what. Value means we can even pass a value into that variable a or b or c. And the type of the variable. Type of the variable is simply nothing but what type of variable we are using it. For example, we are using a. A variable is of integer type. Okay. B variable is of character data type. C variable is of float data type. Okay, that is what it is. Data is stored internally in memory, externally on disk or tape or input from from an input device. Okay, don't get much confused. We will see what and all are those things in the coming slide so that you can understand more clearly. In general, if you want to understand, the data types are of two types actually: primary data type and derived data type. Let me have the pointer. Primary data types, in C language, we are having two types of data types. One is primary data type and another one is a derived data type. Okay, in primary data type, we know what actually the types of data types will be actually. Primary data type is simply nothing but a predefined data types. Okay, in derived data types, we are going to have user-defined data types. User-defined data types are nothing but the data types which we are going to create as per our convenience. Okay, so such type of data types are called as derived data types. Okay, and primary data types are predefined. They will be already defined in the system. We can simply use it by the keywords int, short, long, float, character or char, double, long double. These are the different other types of data types that are predefined or available in the C language. Okay, and many are there. These are few. Okay, the most common data types which all the programmers use or the person or the beginners use are like int, char, float, and double. Okay, we have seen this slide. Okay, the memory. What is the measurement of the memory unit actually? So no need to explain it again. These are the different types of data types and the format specifiers. What actually is the format specifier? Format specifier is like the way how we can make understand the system that which type of data type we are going to display. Okay, we can even declare a variable of integer type a. Okay, and while displaying, if we are not going to give the correct data type, the system will get confused. So we are supposed to say the system that you are supposed to display the integer data type of variable a. So we need to tell that if we are declaring int a, so we need to define it with the percentage d. We need to say that the variable what the system is going to print is of integer type. So we need to write a percentage d as a format specifier. Okay, and when you are using a character, percentage c. When you are using a float, you are going to use percentage f. Like that, many other data types are there. We will see all the data types with examples. As of now, we will see the most commonly used data types: int, char, float, and double. Okay, and we have seen this slide also yesterday. Each data type will have some value ranges, how much data it can, how much value it can accommodate, from which value to which value it can accommodate. It doesn't mean that if it is been given a variable, that particular variable can store how much data we can give. It doesn't mean like that. Okay, for example, if you are having a bag, okay, and if you are asked to bring some provisions, okay, you can bring provisions how much that particular bag could accommodate. Okay, that is what you can bring. If you still want some more provisions, what you need to do is you need to carry some other bag. Similarly, each and every variable assigned of some data type, let it be an integer or character or a float or whatever it could be. Okay, each and every variable of any data type, let it be integer or character or float or double or whatever it might be, it can store some amount of data or it has some range how much it could accommodate. Okay, and if you are going to declare int a, that a variable will be having 4 bytes of data in the memory as a reserved place. Okay, int a, for example, we have given here. Okay, we have given here int a. Okay, this int a will have 4 bytes of data stored in the hard disk in your store. It will reserve 4 bytes of data in your hard disk. Why? Because if you are giving some values, for example, if you are passing value 2 or 1, whatever it might be. Okay, if you are given a equal to 1, okay, it means that one number or one value is being assigned or moved into the variable a. Okay, if you want to display that variable in result, we can write a print statement. We will make it clear while discussing itself so that you can while explaining so that you can make it clear. Okay. Value of a you need to print, right? A is, so we are trying to display the integer variable value. So value of a is percentage d. Why? Because it is of integer type. So I will write it like this. Okay, now I will try to compile the program. Compiling means Alt F9. No errors. I will run the program. No errors. Value of A is 1. So I have got the result like value of A is percentage. In the place of percentage D, I will get the result 1. Okay. Try to change this. Look good. Okay, next. If I want to print the variable B on the screen, okay, we need to move some value into the variable B. So if I want to move or if I want to assign some value to B, like I will assign a D. So if we are going to move a character type of data type into a variable, okay, we need to give it a mandatorily within the single quotes like this. So B equal to quote D and quote, single quotes we need to give. Okay. So while displaying the B, value of A is percentage D. So you can anyone say that value of B could be what we should write? Percentage C. Okay. Okay. A comma B. So I will try to compile it now. Alt F9. No errors. Run it. Value of A is 1 and B is a D. Okay. I will try to write CLR SCR here so that it will be little bit clear. CLR SCR is simply nothing but clearing the screen. Okay. Now we are having another variable C of float data type. Okay, I will give some value to this C variable. The value could be like 1.5. Okay, now I want to display this. I will say what is that slash n so that you can understand it clearly. Value of C is we are displaying a float type of data type, so percentage F. Okay, and here comma C. Okay, now why I use the slash n here is I want to display this particular value of A is in one line, and slash n represent while printing slash n will say the control to move to the next line to print the next is the next value. Okay, value of B is okay, and next slash line will say that again it goes to again move the control to the next line to print the next available statement in the same printf statement. We can write n number of slash n's in a single statement. If there is no restriction that we need to write only one slash n or two slash n's like that. Okay, we can write n number of statements, n number of slash n things. Okay, we will compile it. No error. See, Value of A is 1. We have given like that. Next value of B is a D. I have moved D into B. Next value of C is 1.5 followed by 5 zeros. Why? Because I have simply given 1.5 here, but float variable will defaultly display 6 values or 6 digits after the precision, after this particular dot. 1 point, after point it will display 6 values or 6 digits. Okay, so it is displaying 6 digits, 1.5 and 5 zeros. So including 5, we are going to get 6 digits of the number after the precision point. Okay, so that is what actually we are going to understand here. Okay, fine. So each and every data type has its own storage size. Character will have 1 byte, unsigned character, which is going to carry only positive values. It will also have 1 byte of data, 1 byte of size. Signed char, which can store both positive and negative values, which has 1 byte of data. Integer, positive and negative values are there. It can store 4 bytes of data. Unsigned, which is of positive values, it will store 4 bytes of data. And the short int, this holds both positive and negative values, but of some other big range, so it can have again 2 bytes of data. Unsigned short int, 2 bytes of data. Okay, long, it holds 8 bytes. Okay, so we are going to have some other type of big value, so it has 8 bytes. Next, float will be having 4 bytes of size. Okay, like that. Next, we have seen this one yesterday. Valid and invalid identifiers. What is this identifier? Identifier is simply nothing but the variable what we are going to use. Here, int A is called as an identifier. Okay, and we are going to say that the identifier must be used basing on few rules. The rules here are like the identifier should start with the alphabet. That must start with some sort of letter A, B, C, or whatever the name you can give it. Okay, even you can even give the name John. Okay, John, no problem. You can even give John name as a identifier. It can take it. It is not a keyword. Okay, this particular identifier should start with alphabet, and it should not start with a number. It should not start with a number in the sense that it must not be like this. 1 John. It must not start like this. It must start with the alphabet alone, not with a number. It must not start with 1, 2 John or 1 John, something like that. It must not start like that. And the identifier should not be a keyword. The keywords here are like predefined words which are available in the compiler or in the C program. Here the predefined words are like void, main, hash include or stdio, conio, okay, char, float, clr, printf, get ch. These are the few keywords available, few keywords as of now we know, and we are not supposed to use these type of keywords as identifiers or variables. That is what here we have. Identifier can contain combination of digits and characters and underscore. Fine. This is also some other good example. We will see. Fine. Now, if you want to say that John, if okay, I will say some example. If you want to include two students' name and whose students' names are similar. For example, we are having two Johns in the class. Okay, so we can write John underscore 1 comma John underscore 2. like that, or followed by their roll numbers, whatever you want, you can give it like that as an identifier. This is one method. Okay, and now I have a variable John. Okay, if I give like this or like this, okay, we are having four types of identifiers here, four types of variables here. A equal to 1, A is one variable, JOH and small j, small o, capital M, small n, capital H, capital N. So small h, small n. Okay, this is one variable. Okay, and this is another variable because all the variables are here are of capital letters, and the first letter here is capital and the rest are small letters. So this is different, this is different identifier, this is different identifier. So we are having a different three identifier types here. So we can't, the system cannot justify that whether it is a small letter or capital letter. If you are going to give capital letters of different identifiers, it will take as two identifiers. So the system will not understand it as a small letter or capital letter like that. Okay. Identifier names cannot start the digit we have discussed. Keyword cannot be used as identifier. A name and uppercase and lowercase are distinct. This is what you need to understand. I have written John in capital letters and small letters, and starting with capital letter and the rest all the letters as small letters. So if any letter of a identifier is of a capital letter or small letter, they are different, it will take as a different identifiers. So we are having a few keywords here, okay, and we can say that mostly all the keywords are present here, and many are there actually. Few might be missing here. Okay, auto, break we haven't used here. Case we haven't. We have used char just now. Constant is there. We haven't used. Continue is there. We haven't used. Default is there. Do we haven't used. Double is there. It is of data type. We haven't used else. Else we didn't use enum. Extern float we used. Far is there, we didn't use. Go to is there, we didn't use. If is there, we didn't use. We used int. Long, register, return, short, signed, size of. We are having these kind of different keywords, and these different keywords cannot be used as identifiers. If they are going to be used, the system will automatically show you an error that a keyword cannot be an identifier like that. Okay. Next, we are having a different escape codes here. Okay, we have just used this escape code. Okay, it means that it will move to the new line. We are having slash a, it will give some sort of audible alert sound. If you give in beginning of any sentence, okay, while running the program, you can hear some sort of a ting sound, like the ting sound will be heard from the system. In laptop and all, we cannot listen that kind of sound. Okay, if we are going to give this in a desktop computer, we can hear that sound. Okay, next slash v backspace slash f form feed. We will see what each thing is when we are going to study about this. Okay, so no need to worry. These are the different escape codes available, and we are having some sort of meanings. When we are discussing about that, we will understand what each escape code is and what does it do. Okay, as of now, we will simply understand the meaning of slash n. Just that is enough. Why? Because we are going to use slash n only now mostly. Okay, now this program, we are having a program here which defines the size of a character bit. Okay, the character bits maximum value, character bits minimum value, like that. I will simply type this small one single line so that you can understand. Okay, and one thing you need to understand here is, okay, we will see that and we will understand so that we will be clear. size of char some issue with my keyboard actually. If I type, it is automatically going to some end. Size of char percentage d, okay, slash n. I will use the same thing. Slash n. Char underscore. Okay. Char underscore bit. So what does it denote is actually we are going to display the character bits size in the system, how much of size it is going to take. Okay. Now what we can do here is that, so see, we will get some error here. Why? Because we are having some space here. So I will compile it now. Some error. Fine. Undefined symbol char underscore bit. What does it mean? Okay. This char underscore bit is some kind of attribute. Why? Because see here, I have written the attributes here. Okay, here A, B, C values variables here. I have written the A, B, C variables here. When you write this as a, when you consider this one as a variable, this particular char underscore bit should be declared here. Okay, so it is showing that it hasn't been defined in the variables when it has been declared. So it is not yet declared. So it is asking that we need to declare it. Okay. Okay. Another thing I will do before going to this. I haven't declared a b variable anywhere, right? I will write like this. Alt F9. I have two errors now. Undefined symbol character bit and undefined symbol AB. I haven't declared AB anywhere in the declaration part. We call these three lines as the declaration part. Okay, I haven't declared anywhere AB here, so it is showing me some sort of error. Okay, so if I try to remove it, I won't get that error now. See, similarly, char bit is not defined anywhere here. Okay, but one thing what you need to understand here is what we are trying to do is we are trying to display the value of the char bit that is present in the system. So we know in the sense when you understand that, you will know that you are trying to display some predefined value of a data type here. So this will be predefined in the system. So we can write here this function hash include, yeah, write it in capital letters. So I have changed it. Limit dot h. I have given it here like this. Limits dot h. Limits dot h. Now I will compile it. I didn't get any error now. Why? Because this char bit is a keyword that is present in the header file limits.h. So if I compile it, I am not going to get any error. Now I will try to run the program. Control F9. Size of character is 8 bytes. Okay, that is what. I haven't given a slash n here, so it has displayed it in the same line. I have given the slash n now. Okay, okay, I will give slash t. Slash t means it will print with some distance. Slash t after a tab. Okay, Control F9. See, some sort of distance is been present between 1.5 followed by 5 zeros and the size of the char. Okay. If I give a slash n, it will print in the next line. That's it. The result is displayed in the next line. Okay. So that is the difference. So each we are going to have different type of character data. I mean data types, which can print its maximum value and minimum value. Okay, I will do another one also so that you can understand. Char underscore max. So the maximum character value is 127. So minimum is minus 128. Correct. This is available here in the range. This is the minimum value. This is the maximum value. Character, we have seen characters, minimum value and maximum value. Okay. Like that, we are having a different data types, minimum value, maximum value, longs, minimum value, maximum value, shorts, minimum value, maximum value, unsigned character, maximum value, unsigned long, maximum value, unsigned int, maximum value, unsigned short, maximum value. Like that, we are having different types of data types values. You can check it. Okay. In tomorrow's video, you can find these. I mean, you can find this slide. Okay. You can test in your system. If you have system, you can test it. I will after today's class, I will send you the MS-DOS software installation link. Okay. It is simple. It is very simple to access it. Actually, I will send you the link. You can install it and you can use it. Okay, the shortcut will be available to you on the desktop. You can open it and you can go to the file and view and you can open the editor. Okay, you people might have been understood so far how to open the editor and how to type the program. We are discussing about the C program from the past 3 to 4 days. So you people might be in a position to open the editor and type the program. Okay. Next, we are going to do some sort of integer calculations here. Okay. Now we will go to this program again. Integer A, 1 is there, B is there, B equal to 2. Sorry, I have declared B as a character here. If I declare B again here, it will throw me an error. So I will declare a D here. Okay, I have passed this D as a variable in B, so it is not a problem. I can declare a D variable here. So I cannot declare C here, so I will give E. Okay. 3. Okay. So what we need to do is print f of sum of A and D is percentage D, comma A plus B. Directly I can find the result. I will make these statements as comment so that it won't be confusing for us. Okay. Alt F9, no error. What I'm going to do now, I'm going to check the result of A and D integer variables, and we are having a 1 in A and a D in, I mean 2 in a D. So the result should be 3. I will run it. Correct. The value of A and D is 3. Okay, we will do one thing here. We will try to display percentage D here. Value of A1 and D percentage d, and we need to give the variables here, right? So a comma b comma, so this percentage d will be displayed for this variable, this percentage d will be displayed for this d. Okay, this percentage day will display the a and the sum value. So what we need to understand here is that even though we give n number of percentages, percentage d's here, okay, we must give the order in which the variable should be displayed. If I give d here and if I give a here, it will display the d value here and a value here, it won't be correct. So we must have sense while displaying, while writing the program here. So you need to understand in which order the variables are printed. In that order we need to write the variables here. Okay, value of a is 1 and value of b is 2 and the sum is 3, correct? Fine. Similarly, if you want to do some sort of subtraction, okay, value of a minus b, control F9, I'm going to run the program and it is displaying me the result of minus 1. 1 minus 2 is a negative number, right? So 1 minus 2 is minus 1. It is showing the result. So multiplication, a into d star we must give for multiplication, not x. Okay, control F9. 1 into 2 is 2. So 1 divided by 2, how much? Control F9. We are getting the result as a 0, but the actual result is 0.5. Okay, so if I display it here like this, format like a format specifier like percentage f, I may get the result. Let us see. No error. Running the program. Still I didn't get the result. Why I didn't get the result? Okay, there is some issue with the compiler. So we are not supposed to do like that. When we are going to do like that, we are going to uh, declare the variable and we need to pass the value such that we can get the result. Okay, so the result is this. So we will just have addition as an example and conclude it. Fine. We are going to have like this. Okay. This is what for floating point calculations. Everything is declared here as a float xy. Okay, and if we are going to do some sort of calculations for plus into minus and divided by and all, we may get the results here, the same thing. Okay, this thing you can take it as an assignment for tomorrow. Okay, we have seen the integer calculations today. Okay, means integer calculations is simply nothing but I have declared here integer. Okay, and I have given the integer values 1 and 2 for a and b, and I have seen the results. If you are going to see for float, you can pass the values or you can initialize the values like this 1.5, how I have given here. Like this you can give. Okay, 1.5, 1.6, it is up to you what values you give and you can check the result. Okay, it is also the homework for you. Try to do it. If you face some issue, let us discuss on Wednesday's class. Okay, and next we will skip this slide. Next is variables and constants. A variable is a varying value at runtime is called as a variable. Means a variable can have some sort of changing values when we are executing the program. We will see that in different programs. As of now, you simply skip that particular point. A variable has a number type used to hold some data temporarily. That is what actually the data type. Okay, the variable we know. The value of a variable can be altered or modified later at any time in the program. We can give one value in the beginning. Okay, like this. We can give one value like a equal to 1, Okay, and after a while, we can even change the value of that particular variable so that the last value, whatever you give, that will be displayed on the screen. Okay. In about declaration, A and B are integer types. A, B, C are integer types of data type. Okay, and C, D, E are of float type of data types. Okay, we are having two types of initializations here: static initialization and dynamic initialization. We will see this one today, and we will end the class. Okay, static initialization. So far, we have seen these kinds of initializations. Means passing the value into a variable in the declaration part is called as static initialization. Okay. When it comes to dynamic initialization, we are going to give the input to the particular variable in the runtime. The runtime in the sense during execution. We will see that now. Okay. See here. Now we are having a int a equal to 1, b equal to 2, e equal to 3. So we will try to remove this, create some sort of confusion for you. Okay, a equal to 1, d equal to 2, e equal to 3. I will keep this one as a comment. A equal to 1, d equal to 2, e equal to 3. Here, what we have done here is we have declared three variables a, b, and e. Okay, these three variables are declared as integer data type, and we have passed some values in those variables a, d, and e respectively, like 1, 2, and 3. Okay, what does it mean is a variable will have 1, b variable will have 2, e variable will have 3. Okay, so what we have done is we have passed the values into the variables a, d, and e. This is called as static initialization. Okay, declaring, this is what declaring is. Int f. This is what declaring is. If I pass a value, this is called as initialization. Means we are initially passing some value into the variable, so it is called as static initialization. Okay, now we will declare int g variable. Okay, and I will try to take input from the screen while execute. It is like enter value for g. Okay. How we can enter the value? We will see that one also. Now I will compile it, no errors, and I will run it. Control F9. Sum of A1 and B2 is 3. We got the result. Fine. Now I will put slash n here. That makes meaningful. I will run it again. It is asking for enter the value of G. Now what should I do is I need to enter the G value here. Okay. If I try to enter the G value, okay, I will enter the 4 now. If I press any key in the keyboard, it will go to the program. Now I am pressing 4. See, it is going to the program directly. So what does it mean is in the runtime, it is not going to take any input. Okay, to make understand that I will enter the input during the runtime, we must write some other statement called as scanf. Okay, that is what present here. Okay, that is what present here, scanf. See, okay, scanf. What does this scanf mean is actually this scanf will initiate the system that we are supposed to take some input from the user now before displaying some other statement. Okay, this is what actually the format is. It is much similar to the printer statement. Okay, scanf of percentage. I am declaring this G as integer type of data type. So I am supposed to give percentage D and I need to enter the variable G here. If I give like this, the system will not take the value what we give in the runtime. So what we need to do here is we need to uh, uh, include some symbol called as the AND symbol here, such that the G value will be taken from the screen and it will be stored in the memory location. Okay. Now we will see what is that ampersand symbol and all in the coming slides and in the coming sessions, so that you can understand more clearly. Okay. As of now, the syntax and the format will be like scanf of percentage D. Okay. Next, what we will do is we will print the G value, printf of G value of G is percentage D and G. While writing a scanf statement, you must write this kind of ampersand symbol or and symbol. In print statement, it is not necessary. Okay, now I have done a mistake here in this particular printf statement. It will throw me an error. It is like I didn't give the comma value here. So it will show me some error if I compile it. So I am going to give the comma here and I am going to compile it now. Alt F9, no errors. Next, compile, control F9. It is asking to enter value of G. Okay, what I will do is I will enter the value of G as 5 and I will press enter. We are not supposed to press any other key after entering the value during the runtime. Okay, if you enter the value, you must press enter. Okay, and we have given some other statement to display, right? The value of G, it will automatically display. Okay, so first this statement is printed. Sorry, this statement is printed. Okay, we will make this one also comment. It won't be confusing for us. Okay, it will ask to first, it will first display this statement, enter value for G. Next, it will take the input of G and automatically after entering the value and pressing enter, this third statement will be displayed. Okay, I will run it again now. Control F9. Enter value for G. I will enter 3 and I will press G. Sorry, enter. Value of G is 3. Now we are having two statements. This statement is executed first and it is expecting some value to be entered in this statement. Okay, and this statement, the result will be displayed in the last after entering the value. That is what. This is what actually the dynamic initialization is. By using the dynamic initialization, what we can do is we can give the result, sorry, we can give the input in the runtime. Okay, runtime is simply nothing but this is what the general mode. Okay, we can compile it, we can execute the program. During compilation, during executing the program, if we give any variable or if we give any value, it is called as a dynamic initialization. Okay, so we are going to give the value to a variable G in the runtime. This black screen is simply nothing but runtime. Okay, it will take the input and it will display to us spontaneously. That is what the dynamic initialization is. Giving values, I'm repeating again, giving values in the initial part of variable declaration, we call it as static initialization. And while giving the values in the runtime, it is called as a dynamic initialization. There are two types of initializations available: static initialization and dynamic initialization. Okay. Now we are having a, we will see this one also, local variable and global variable, or shall we end the session? Okay, we will see this and we will end the session. Okay. We are having different types of variable. Okay, one is a local variable and another one is a global variable. Okay, local variable is simply nothing but the variables that are declared inside the function, a main function, and the global variables are simply nothing but the variables which are declared outside the main function. You people may get doubt what is this and why we need to worry about the where it is declared. It makes sense actually. Okay, we will see some small example. If you want, I mean, if you have a two-wheeler and if you are having some sort of parking facility available in your home, you can park your two-wheeler inside your house in your parking slot. Okay. If you don't have a parking facility in your home and if you want to park your vehicle, where you will park is you are going to park your vehicle in front of your house, which is simply nothing but the road. Okay, so it is going to be the public place and the parking available inside your house is a private place. No other person is going to park their vehicle inside your house. If you are having space, it is your private area. If you are not having any space available, you are going to park the vehicles outside the private area, which is simply nothing but public. Anyone can use the public area. There is no restriction that you should only use and it is in front of your house. It is not like that. So anyone can use it. So we are going to have some sort of global variables and local variables. Local variables are the variables that can be used for that particular function. Okay. Now we are having a void main function, and I have declared the int a, d, e, f, and g. These five variables, these five data types or of local variables to the int main function for the main function. Okay, now if I have a variable here declared, this h variable is called as a global variable. So I can access this h variable from any other function. Okay, suppose I am having main function one here, and then if I'm going to have some other function, okay, if I declare a variable here in main function, if I want to use this a in some other function, I can't use that particular a. If I declare a here, okay, and if I want to access this particular a from any other function available in the program, I can access it. Okay, so declaring a variable outside the function is called as a global variable. Declaring the variable inside the function is called as a local variable. Okay, there are four types here: global variable, local variable, automatic, and static variables. Global variable, void main. Okay, this is the function, and this int c and char d are local variables. Int a and float b are global variables. Okay, the variables which are declared outside all the functions, not only the main function, below the header files like hash include. If we are going to declare it there, those variables can be called as global variables, which are declared outside the function, including the main. Okay, is called a global variable. Not only under, I mean, not only outside of main, all other functions it should be outside. So such type of variables are called as a global variables. Next, local variables. The variables which are declared within a function are called as local variables. So int c and char d are local variables here. Next, automatic variables. These automatic variables are simply nothing but local variables again. We have having some other name here, so we are going to call it with the automatic variables. Next is static. They are they are called as static variables which are declared local to a function. Means only the statements in this particular main function can access this b. Okay, if we are going to have we are going to try to access it from some other function also, this static keyword will say that you are not supposed to access this particular variable. We will see when we are going to study about the different functions that declared in a program. As of now, you simply understand what is a local variable and the global variable. That is more than enough for you for today's class. Okay, so we will end the class today, and we will see the next topics in the next class on Monday. Okay, and I will give you the DOS box link in the WhatsApp after the session. In another 5 to 10 minutes, you can install it, and you can try practicing by seeing the today's video tomorrow. Okay, thank you guys. And any doubts? Any doubts, please? Okay, I will end this session. I will stop recording.